Hello, everyone, and welcome to Brno Mobile Conference. My name is Vladimir Šimše, and I will be your host today. I know that the current situation is not very good, but I am happy that at least we have a chance to meet in this form. And that you will enjoy Brno even in this online version. Today, you will hear talks about various types of multi-platform development and delivery. ReNative, Xamarin, Flutter, or even payment cards. Unfortunately, one of our guests couldn't join, but nevertheless, the event is full of great talks. And now let me introduce our first guest, Pavel Jacko. Pavel is a CTO at 24i, and I like really this quote. He's a person who always considered programming as an expression rather than desire. He will tell us something about how he sees ReNative as a tool for multi-platform development and mindset. If you have any questions, feel free to ask on our Slido channel, which you now see on the on your displays, or you can type in #Brmo there. So without further ado, please, Pavel, the stage is yours.
Okay, so the title of the talk is Unified Platform Development with ReNative, and I'm gonna dive a little bit into the kind of a background behind this talk. So, as most of the people who joining know, building truly cross-platform apps is something which has been around for quite a while, and ReNative is not the only. Not the first and also not the only cross-platform tool out there. However, I believe that ReNative was the first open source framework which got us thinking about cross-platform in a way that it would involve the community, it would involve the open source, it would involve sort of slightly different way of thinking. In terms of the components and the areas around general cross-platform development. And in this talk, I'm gonna touch a few topics and concepts related to how did we try to take ReNative into the next level. As you know, the world is now slightly different, and there's a lot of other areas around the multi-platform development, cross-platform development than it used to be in the past. And I'm also going to explore how ReNative is helping 24i to unlock the potential of ReNative and bring kind of into the new realms of enterprise scalability, unified platform approach, continuous deployment, rapid templating, in a way to allow us to deliver industry-leading OTT platform to the market. So I've been already introduced, so not much extra to say about myself. Maybe just the extra things about the fact that I've been in IT industry in a variety of lead roles for 15 years, and despite that, I still love programming. I do programming day to day. I really enjoy it, and I hope that I can stay in the realm of development into the future as well. Okay, so maybe every topic is probably good to start with the question why, and in this case, probably it's good to ask why did we choose ReNative in the first place for our solution? Well, the points you're going to see here, I don't think they come as a surprise to anyone. It's a pretty well-known list of facts. ReNative is community-driven. It has a good code reuse and cost saving. It has a ability to do rapid development with live reloads, really neat feature. It's easy to learn, especially the basics. Native performance is achieved on a mobile environments, which in other comparable stacks was not. We were not able to do that in the past. So it was one of the first platforms to kind of give us this opportunity to take advantage of the native rendering stack while introducing JavaScript as an abstraction layer. It's also modular in an intuitive architecture, similar to React, very similar. So anyone who done React would feel fairly at home. It is mature enough at this point. It has a JS abstraction and hooks, which I personally love, and many developers choose React and React Native also because of these neat features. And it has this mantra, learn once, write everywhere. Now, this is a little bit of a subject to terms and conditions. I'm going to explore those a little bit later. So when you look at this, it feels all good and all great. So what is the problem? So I think, talking about the React Native in a way, how it works and what it does, there are tons of talks and tons of experts who could talk about this. So what I want to focus on are the bits which are problematic. At least they were problematic for us. And if I would go through those, the list of the problems, maybe we can start with how React Native started. It was around 2015, if I'm correct, when React Native was introduced in its beta form. These screenshots are not respective to the dates, of course, but you can kind of think of the world of React Native when it first introduced iOS, and then a little bit later, it wasn't at the same time, but a little bit later, it also introduced Android. And if you were building React Native applications, that was pretty much the world you were in. And it was a happy world. It did solve many problems which other solutions were plagued by when it comes to rendering, when it comes to decoupling of the components and so on. But we're not in 2015 anymore. We are in 2020. In fact, almost 2021. And the world in 2020 is a little bit different. And suddenly, React Native as a framework to deliver cross-platform functionality. Cross-platform is maybe a little bit misused word or quite a vague description of what does it really mean. Because you could say, if I'm running on iOS and Android and I deliver a mobile solution, it's already a cross-platform. But the world into 2020 is much bigger. And it's not just about the different platforms, different operating systems. It's also about different form factors, different ways how to interact with them, and so on. So the world is much more complex, and therefore it is also posing a bit of a problem if you want to think of how to build truly cross-platform solution in a way that it's also scalable. So if I would go through the list. So cross-platform beyond iOS and Android, the form factors, rapid template bootstrapping, scalability versus customization, holistic dependency management, plugins based on a dynamic configuration, complex product development and QA flavoring, unified build pipeline, CI ready out of the box, plug and play integrations, continuous product updates. Those are one of the few problems we encountered when we try to scale up. And also when I personally work on several React Native based projects, those were kind of persistent issues. Every time you would kind of try to go beyond the standard solution. So let's dive into a little bit into those topics. So about the form factors. So what does it mean? So if you think of a single code base, and React Native is not about single code base, it's about learning in one way and applying in a different variety of different manners. Nevertheless, if you start adding more form factors on top of what React Native does already, you encounter an issue. The issue is the fact that the single code base, even it would be possible, it's not even desirable in this sense, and it's not desirable from a variety of different reasons. But I think the form factor in terms of UX and UI and the user experience is probably the most obvious one, is that you don't want to build a sort of a experience which feels exactly same on the mobile, on the tablet, on desktop, on a big screen, or even on wearables and further down. It's not just those. So that's a first problem. Another problem is the interaction method. If you think of that, a couple of years ago, the only thing you could interact with was essentially your mouse. Introductory of iPhone and prior to that, of course, several different Android devices and other smart devices introduced sort of a touch kind of a dimension to the way how you interact. But of course, as the technology progresses, more different form factors were introduced. Suddenly, we deal with way more than just that. We deal with the key event handling, the focus management, the gesturing, even without the touching, the voice control, the variety of different input devices, and all of them are potential targets for a problematic solution delivery if you think of about truly cross-platform solution. Another thing which might not be prevalent immediately, but it is prevalent quite a lot behind the scenes, is the navigation. If you think of navigation and the way how it works, it's pretty obvious on a mobile, and Android and iOS are very, very similar. They're similar form factors and they similar way how they work. It's not the same case if you start adding all these different areas of OS ecosystems. For example, if you want to navigate, let's say, to another page, let's call it a page, it could have a different meanings depending on what device you're looking at. On some devices, there is no such a thing like a page. Some devices cannot have a menu you can open and navigate. Other devices or other platforms like a web, you could just navigate to any page at any time. You need to think of the breadcrumbs, you need to think of the history. So suddenly navigation, which in the realm of standard React Native project will be as simple as navigating around specific pages like stacks, suddenly becomes a little bit more complex. Functionality is another problem when you think about large scale cross-platform solutions. Platforms differ when it comes to a built-in functionality. Think of the TVs, if you compare them to the mobile. So what the mobile do, on the mobile you can do a variety of things like gestures, you can do things like share functionality, so sharing your content. On TV, you don't always have this functionality. Same thing with things like camera. The ability to make a split view is another thing, is like a native functionality on modern tablets. And we're not talking only about the iOS and Android. We're also talking about the Windows and Mac OS and other platforms which have a slightly different means of what does it mean that they can offer to the developers. And it's quite difficult to take advantage of all of these different natively available functionalities if you don't have a sort of a good structure in a way how to consume it and how to incorporate it in your project or in your product. Same comes with the plugins and variety of different integrations. This always presented a problem. In the last couple of years, I've been doing cross-platform development. That always comes as a bit of a pain. Underlying architecture is another issue which might not be apparent at the first sight, but it becomes apparent once you start scaling your solution. For example, if you think of how the platforms fundamentally work, again, iOS and Android are very similar in the way how they operate. You have JS Core, you have your rendering pipeline, and the only thing what they really differ is the way how the native stack is rendered because of underlying differences in iOS versus the Android ecosystem. But if you would go a little bit further, there are platforms which rely on the web frame, which are things like HTML-based smart TVs. The websites, for example, they don't work only on a standard. They don't work in a kind of a standard client way. They also quite often, these modern websites incorporate server-side rendering and other potential solutions. So suddenly you need to think of not just about what do you code, what do you write on a client side, but suddenly also what does it mean to essentially build and run your app on the server at the same time. With the smaller type of devices, again, a very different way how the underlying architecture works. So this again, while you can have a kind of a cross-platform tooling, they do manifest themselves in not just in it's very hard to abstract it basically into sort of a single function which can cover it. Developers who would build these cross-platform solutions would have to think about these. They are unescapable fundamentals. Another a problem when you build in cross-platform apps is, of course, deployment infrastructure. Every platform has a very unique way how it's required to be built and deployed. And if you think of the way how ReNative works, essentially it's about it's a rendering framework really mostly, and it lets the native projects to handle the rest. So if you think of what does it mean if we want to create a special CI integration where we would run these projects in a way that we can build them with custom parameters, or you want to deploy your dependencies, or you want to manage the way how you flavor your project. Suddenly, you have to dive into the realm of these native. Of these native environments in order to truly make your solution scalable in a proper way. So this is again unescapable fact that many React Native developers do need to be a good native developers in order to take advantage of React Native at that scale. Already mentioned a little bit. Product flavoring is another a painful point. Quite often in a larger project, you do require to build sort of a pipeline which allows to create a flavor. So whether it's for development purposes, things like building a staging versus alpha versus automation versions with a different plugin integrations and different IDs and so on. They also might differ in production. Sometimes, especially when you're building a product, it's nice if the product can support, and sometimes even required when the product can support these different flavors that these different, for example, these different apps could be deployed into let's say app stores and play stores under sort of a different realms. They have a different iconography. They could have a slightly different features and so on. So again, this is a fairly common problem, which becomes very apparent as soon as you start scaling up your product into this level. Another issue, which is quite a headache in development in general, and especially in front-end development, is the fact that the products tend to be either highly scalable or highly customizable. And it's quite hard to do both of them at the same time. An analogy would be some teams or some companies decided to build the products sort of in a way as a template, which allow them to sort of configure them. And think of this as essentially ordering a car where you can still customize it, but you can customize only a certain things. You can customize your color. You can change maybe the engine output. You can change the color of your seats, and so there are certain things you can do, but they are predefined because they're predefined in factory in a way how these cars are assembled. If you want to build a highly customizable solution, you typically need to resort into sort of a way that you start putting these different sort of components together in a variety of different ways. And suddenly to kind of combine these two is typically quite a challenge. It's not impossible, but it requires much more effort to get to that level. Another problem is product complexity. So if you create scalable cross-platform solutions, creating them in a way that they work really well and they can scale is an ever-present challenge. If you think of your project when it starts, and maybe some of the guys who are online experience this little arrow, which is as the size of your product or even project increases, so does the time to maintain. And the time to maintain is not proportional. It basically means that every feature, every bug fix will take longer and longer because it becomes sort of a convoluted infrastructure, and it becomes essentially unscalable. And at some point on certain projects, and I went through fair share of projects like those on above ends, you reach the point of no return. And that basically usually means that you have to rebuild your solution from scratch, because either it becomes obsolete or it's just too much of effort to maintain it. So really the problem is how to achieve the level of scalability which can scale gracefully. The time to maintaining and the cost of maintenance scales gracefully with the size of the product and the features and so on. So that's another problem. Go to market, another issue with the building cross-platform solutions. Minimizing amount of time to go from concept to live requires a lot of extra scaffolding. So think of this, that if you have a template you built internally, you use for this type of deployment, how much time does it take to build and maintain this type of environment, whether it's for the component-based infrastructure or templating system, whatever it is, and then you're putting it together. And typically, especially in a large-scale application development, if you're building something for customers, you end up still spending time on extra development, whether it's a customization, extra features, or certain tweaks you need to do, and then how long does it take to finally push it all the way to all the way live, which in applications typically means some sort of a store, or even websites if you deploy it directly on a website. Another apparent issue, or the issue which becomes apparent if you start dealing with more than one or two platforms, is that every platform has a different way how to deal with the security of a sensitive data. Things like distribution keys, the authorization keys, the key stores, and anything which allows you to sort of make your build, but at the same time, it's not something which should be freely available. And how to have the way how you can manage all of these. That typically what happens is the teams either use things like 1Password or there are some third-party solutions as well, which allow you to kind of cross-integrate it into the code base. But as you add more and more platforms, typically they don't cover these areas out of the box. So it becomes again an issue to think about. Okay, so those are the problems, and the question is, how did we went about to solve them? So we didn't want to abandon React Native. React Native is a great technology. It's not a silver bullet. Nothing is. But something had to be done to overcome these problems. And this is really where the story of ReNative starts. So as many other frameworks or solutions, it started quite in a humble way. It started as a bootstrapping template for React Native projects. When I say bootstrapping, I mean a multi-platform bootstrapping template, and it allowed developers to basically kickstart a new project in a setup which would allow to go beyond iOS and Android. That's basically what was the initial purpose of ReNative. But it slowly evolved into a unified development infrastructure. And what that really means is that it allowed the purpose didn't change. It was about saving the time of developers so they can focus on what matters the most, which is building a great experiences. It just grew in terms of size and support. Mind you, this whole thing is still in a beta, so it's under active development, and it's also sort of an exercise into this potential future of how far can we really push the limits of technology when it comes to building a truly cross-platform solutions across the whole spectrum of what's available in the industry. Okay, well, that's a lot of talking. So maybe it would be good to give you a little bit of a preview. What does it really mean? I think a picture is worth 1,000 words, and one video is worth 1,000 pictures. I'm not sure if you're gonna see it well, but let's see. Okay, so this is a example of building React Native app for 11 platforms in 8 minutes. And all of this whole session, holy shit. Let me just take it. That's probably better. This whole session was recorded in real time. And you can see the sort of an example of starting a new project essentially from nothing. It's an empty folder. It starts as a bootstrapping exercise. And here I recorded a few details of what ReNative really does. So it basically bootstraps your project. You can pick a template, and then you run RNV CLI, which is kind of similar to React Native CLI. It just wraps some extra commands related to ReNative ecosystem. As you can see, the whole idea is that you can start your project by simply having a single JSON configuration. This is something what I call a DNA. And you see like a tons of windows here. It's simply because I wanted to demonstrate how you can run all these different platforms at the same time, essentially. What RNV does, it works in a very similar way how the latest React Native works on its own. This was actually built before React Native supported a bundler. Automatic bundling or automatic start of bundling, and also a few other things like the dynamic plugins and so on. So what you see here is essentially in real time, I'm building up this new project, which started from scratch. And as you can see, some things are already popping up. For example, the web was just built with the template, which I choose. And I'm just going through and I'm running these different platforms as I go. And the interesting thing here is that what ReNative does really, it simply takes React Native, it decorates the environment around React Native in a way that it allows it to actually target multiple platforms, more than the original target. Of iOS and Android on mobile. And what it really does, what you see here is this is actually running React Native. So all these different platforms, they are rendered. The code base is essentially React Native. You can see things like web, for example, as most of you, I'm pretty sure, are aware of that there are solutions like React Native Web, which in this particular instance, I'm wrapping up as a one engine to transform React Native into the web solution. But also there are specific adjustments made for tvOS to support better focus management. Same for Android TV. As you can see, there are a few other interesting platforms I'm demonstrating here. For example, here you can see that this is Android Wear. So again, what I'm doing in this case is I'm simply running same command, except I'm just passing a different platform. And because this is a single project, with a multi-platform support, everything is basically based on that single source code. Now, I will dive into what does it mean single source code. It's not precisely a single source code. It's a single infrastructure in this case. But in particular, Hello World example, which is a template available for when you bootstrap your new project, it is very close to single source code, just to demonstrate how far you can push that narrative of basically using a same page, same UI components under so many different paradigms, as you can see here. So at this point, I'm just running, it's just basically running through all these different platforms. So I'm just gonna speed up a little bit. Again, this is recorded in real time. As you can see, this is Tizen. This one is a WebOS TV. These are of course all emulators, because that's how I was able to record all of this. And if I kind of navigate a little bit further, so the important part was that for me was that the ReNative was about to help to empower React Native and all these features which everybody got accustomed to. So one of the features I mentioned at the beginning was that it's really cool feature is the hot reload, and the fact that your ecosystem is kind of connected. And you can see here that these are all interactable. And the logic here, it's really hard to read. It's very tiny font here, so you're probably not going to read it. But essentially, what's generated here is the code which I'm able to edit. And I'm just going to skip to the point when there's enough platforms launched. And here, what you're going to find is I'm going to go to open the code base. And there is a page which is actually single code base page, because that's I was demonstrating that functionality. And here I'm gonna make some change. For example, I changed the background color of the button. And the most important part was that the hot module reload and all the kind of cool features of React Native are intact. So basically, this is standard React Native environment from the perspective IDE. And as you can see, this is again in real time. These apps are reloading, and the code just basically changed. So this is like just a kind of a little demo of how far could you push React Native when it comes to multi-platform support. Okay, I'm going to move to next one. Okay, so moving on. So this is all nice. It's quite cool to have all these different platforms supported by essentially single technology. In this case, a React Native. However, it's of course it's not everything. There's a lot of details which I'm going to touch in a sec. How to make this truly scalable as an ecosystem, especially on building scalable products across all these different platforms. So one of the things is if I go to these a few live lessons. So great engineers work hard to not to work hard. That's what I learned over the years. And those engineers are the best engineers because they spend time to make sure that they don't they invest a lot of time to do something, so they don't have to invest time into the same thing again. And this is also sort of a mantra behind ReNative as well. So the goal is to how to get from this 0%, which is basically usually startup of your project, go through a command and get to the 80. And why is it 80? Because another live lesson I learned over the years is that 80% of the project's DNA is known at the beginning of the project. And it just takes 80% of the time to finalize the rest 20. So it's this standard 80-20 rule. And in this case, what I mean by DNA is that if we decided to build, let's say, a taxi application, and we decide to think of the features, what is needed, the interface and all that, fair enough, there will be things which will change, but we're not gonna suddenly change. Our product owner wouldn't come to the developer and say, hey guys, stop doing the taxi app. We want to we want to build a video application. So that's what I consider DNA. And if anyone who's been in as a developer or work in the environment around mobile development knows that once you know what's needed on technical level, quite a lot of things are already decided in terms of the backbone of what does it mean to build that particular product. And really that final 20% is all these nasty things you have to encounter when it comes to building the actual final product. But if you take this basic lesson into the real world, then you could think of, okay, if I can go from 0 to 80 in a shortest possible time, that means I could also go all the way to production. Now, when I say production, I don't mean production as a going live. I mean this is something which demonstrates the DNA of what we're trying to build, and therefore it's something which can be testable, can be presented to the product owners. So the rule is to get from 0 to 80 as quickly as possible, because a lot of things are known at that point, and then to spend the rest of the project just to make the final 20 really great, and spend all the time and effort on that, because that's where the user experience lies, that's where the design lies, that's where the performance and the smoothness of the solution lies. As soon as you spend too much time, anywhere between 0 and 80% as a developer, as a team, something is usually not right. Something probably going to end up not in the right way at the end. So with all these lessons in mind, so how does it really work then? So R&D is sort of is basically just a collection of different areas of functionality, things like SDKs, platforms, templates, engines, configs, tasks, integrations, plugins. As you can see, none of that touches the topic of rendering, because that's what, for example, ReNative does, and it does it really well, and there's no point to reinvent the wheel. That's also not the purpose of ReNative. It's not to start taking over the things which the actual tool, what it's trying to help with, does really well. So it basically is a support part, and the way how it supports it, it's kind of a similar thing as what the React Native does already with, for example, native projects. ReNative generates standalone projects which are not aware of ReNative itself. So it has a quite robust infrastructure, but that infrastructure, the whole purpose of that infrastructure is to help to get to the point when you can take this project and you can run it, and you could take this project out of the equation or out of the environment of ReNative itself, and it wouldn't really matter for that project, because it's just been generated. It works as standalone, and therefore you can also run, debug, profile, and export these type of projects in a standard IDEs, just like normal native projects. This, mind you, works across the spectrum of the different platforms. This is not just for the Xcode, but also for things like Tizen and WebOS and variety of native environments and platforms where you kind of want to get access. That's basically the sort of a premise. And ReNative provides an abstraction of the project infrastructure. So you talk about engines, assets, encrypted data, app configurations, templates, and ReNative JSON configurations. This is the kind of the main configuration you get, but you only talk about that at the point when you're about to make to run RB command. But then once you run it, really you're talking about the actual projects, which then can just simply ship out the final product to the target OS or platform. So unified development is quite a complex world, as we learned. There's tons of plugins, great open source initiatives, tons of different platforms, OSs. It's a quite complex world if you try to kind of put it together. And really, the goal of ReNative is to convert that awesome initiatives into a structured infrastructure. That's pretty much what it does. It takes all of these different cool tools out there, these open source frameworks, and it tries to put them in a way that they kind of go in one direction, and they can target all these different platforms and environments as an output. So customizing ReNative itself, it's built in a way that it should be possible to overwrite pretty much anything. It was never the goal of ReNative to become the sort of the drive force behind the infrastructure. It was just to provide it. And sometimes you do need to go beyond the basics. So you could go from all the way from the absolute basics. As you can see, this bootstrap was an example of starting a new project, and anyone pretty much can start a new project. But sometimes as you start building especially more complex products on top of ReNative, you kind of need to dive into project code, templates, and as you go deeper and deeper, you go into integrations, plugins. You can override engines. You can do plugin overrides directly. You can do build hooks. You can build your custom plugins as always. You can build a custom task execution and even custom engines. Which basically means you could build your own engine, which is not even React Native, and still execute it under ReNative environment. And that's basically what ReNative is just the single entry point before you dive into deeper topics. And that single entry point is a CLI you can run. It's interactive CLI, which allows you to kind of do all these different commands, which is basically manifestation of the configuration files as you move forward. And the ReNative philosophy is you only need one command to get it done. And this is very strong and a very deeply rooted philosophy. The idea is that, and I strongly believe that the future is also moving towards this type of paradigm, is that it's really about what you're trying to achieve rather than how to achieve it. You get to the how to achieve it once you get this initial setup in that idea up and running, and it creates much more room for negotiation, much more room for kind of feedback and so on. So to achieve this notion of being able to run a single command of any sort of a goal you're trying to accomplish, and yet to make sure that everything just works, the RNV has a chain promise task ecosystem. So basically everything what you do is kind of divided into a separate task, and that means that it's possible to also extend it and build extra tasks around. And the example would be if you run RNV deploy for tvOS in your project, what really happens is it actually goes, it bubbles up through export. Is it exported? No. Okay, let's export it. Export ask, is it built? No, let's build it. Is it packaged? No, it's not packaged. Is it configured? No, it's not configured. And so here's the dependency, install dependencies first. And then it goes back to the point and basically reach the top of the command. And that's why you never need to run anything like pre-configure or setup or anything like that. The notion is to basically let developers to focus on only what matters, which is I just want to run this, and then I can focus on the code base. So how does this solve the problems which I described? So this is, we had these issues, and I had these issues on many projects, but at 24 we had these problems we encountered. So let's first go through how ReNative helps to solve these problems. So for example, you can think of the form factors, and what typically happens is that you want to be able to target certain deviations, especially when it comes to UX. So what you can do with ReNative is that you can have this extension system which is built in for each platform, and it's specific for each platform. So you can kind of fine tune your target audience when it comes to the export code. So for example, I show you example of browser, desktop, standard index, which is the final fallback, and the watch. In this way, I can build a component in my page, and depending on which platform I'm running it, it will kind of cascade to the right extension, depending either I'm pointing it as a platform or I'm pointing as a form factor. So, and the final goal and the final kind of a premise is that when I'm actually using it, the only thing I care about is that I import my page and I just render it. So I don't really care what's behind the scenes. This is a very important premise when you want to scale into a large products, where you usually have multiple teams who handle different layers of the productization. So think of the left side is a sort of a product team who's building, let's say, these components, and they know about all these details. And then the right-hand side is a team who's responsible for delivery, and they focus on a customer experience and dealing with the rapid deliveries. And you can kind of create that abstraction here, that they don't need to know everything behind how it works, as long as they know how to use it. So another thing is the navigation, as we touched before. Yeah, so what you can do, you can fine-tune fundamental nav structure accordingly with the extension hierarchy order, which is unique for each platform. So if I decided I want to create an application, and the entry point, typically the navigation is the thing which is most required to be split, because there are so many different paradigms. And you don't want to split your whole code base, your whole code base. You just want to target the specific area which handles that particular problem. And in this case, navigation is typically the entry point. So in this case, I'm showing entry point to the app, and also the variety of flavors I put together, just to kind of fine tune that the different file could have a slightly different navigation system. It could even have a different library used. We could use React navigation in one, and then and Reach Router on another one, if that will be the case. So you're also not bound to use a single framework to do your navigation. And that's also the beauty of the ecosystem, is that it is possible to kind of customize it on every level, in a sense that it allows you to sort of pick just the thing you need to tweak, rather than rebuilding the big part all at once. And here you can see the file extension support. This is generated documentation. As you can see, it's quite long, because when we went through the development life cycles, it became apparent that the need for supporting these different flavors was needed to kind of create the ability for developers to choose the right organization in those files, so they can actually do this right override through extension at the right moment, under the right conditions, which is not always the same. You don't always target the web, and you don't always target the Chromecast. Sometimes you do the TV, sometimes you do a specific native functionality, sometimes you do just non-native, and you have to be able to kind of pick the right override. Functionality. So you can exclude plugins dynamically per platform or build flavor. So this is quite important, especially on many projects I've been involved in, that it should be possible to simply switch on and switch off the plugin easily. And what ReNative does, it abstracts the plugin injection to the level of the configuration. So this is probably the biggest difference, especially in the newer React Native functionality. You can still do that. You can still use the automatic inclusion of the plugins, which is I think it came with React 62, if I'm correct. And the problem here is that if you need to build these multiple flavors, it's sometimes not favorable that you include all these plugins automatically. In order to do that, you would have to kind of go around with, let's say, setting up your pod, your CocoaPods, kind of logic in a certain way. Then your Gradle would have to work, and that's just the Android NAS. And then there are other platforms which could have their own native plugins unrelated to iOS and Android. So again, so abstraction level to the point where you can simply say, under this platform, add this plugin, and under this, remove this plugin. But this goes beyond, because you can also do it per flavor. And I will touch the flavor in a sec. So underlying architecture is another sort of a typical pain point when you build in cross-platform solutions, is that there are certain things which can be normalized. Things like IDs, things like the way how the app can be distributed, the flavoring and all that. These are the things which are normalizable, but they normally, under normal circumstances, you have to target them specifically for each platform. And again, and this is mobile conference, so I'm showing an example of iOS and Android, but again, this touches basically every single platform out there. So the way how you configure, for example, the ID of the app is very different on iOS, and is very different on Android in this particular instance. So what you can do with ReNative, you simply say ID, and that will automatically regenerate the info plist and Android manifest. So there is no need to have extra functionality or scripts around this on the native side. And again, the thing, because it's regenerated, when you open the project, it basically is no longer aware of the ReNative functionality. Simply just say, okay, I have this idea, I can run this project. Deployment infrastructure, another problem I touched before. How do we solve this one? So every platform has a unique way how it's required to be built and deployed. So think of this in a way that when you run something locally, ideally it would be naturally like same way how you run it on a CI, except a few things like few keys and few flags. And that's what ReNative does. It has basically the goal is to abstract it to the level where the same command can be performed essentially, no matter if it's locally, if it's on the developer's machine, or if it's in a let's say running under a continuous integration server. And if you're running under continuous integration server, the only thing typically you're doing in ReNative, you pass CI, which basically means that it removes all the questions because again, CLI is interactive without the CI, so it might ask you things, and if you pass the CI as a flag, the goal is that everything should be predefined, pre-configured. If the ReNative asks the question in CI, it typically means that something is not right because it's asking that question for a reason. Product flavoring is another quite complicated topic when it comes to scaling this into solutions as a product, which can be reused and the projects. And especially again, if we start touching cross-platform environments, even beyond iOS and Android. So what ReNative does, it abstracts this away into what's called build schemes and app configs. So app configs are things like your application configuration. So if you think of project, a single project could have a multiple app configs, which means that you could have a different flavors of your app. These app configs, they don't contain any code. They are simply just the configuration configs. What you can, however, do in app configs, you can inject things like assets. So you can change your iconography, you can change your splash screen. You can also change the way how they inject something into the code. If you want to have a different, once you compile your code, you can compile it into different, into slightly different functionality. So you can also change that. And of course, quite often you need to build these things like debug builds, alpha builds, and typically you have to go through certain configurations on each platform natively to kind of achieve this. With ReNative, the goal was to abstract it to the simplification of simply every platform has a build scheme. As soon as you add new build scheme, it basically is treated as a new build scheme. It becomes available in a console. You can start using it, and anything you pass inside of that object is then consumed as the override for a specific build. Scalability versus customization, another problem encountered. So how do we solve this? So ReNative supports dependency scoping. And this can become really powerful if, especially on really large scale productization efforts, where really what you typically do, you don't build projects, you build products which need to sort of provide the templating and functionality and plugin dependencies sort of from the products, rather than maintaining them in the projects. But at the same time, you must have an ability to override the aspects of the product where needed. And that's exactly what I touched before, is that making this kind of a twofold ecosystem where you can also productize and scale a lot, but and at the same time you can also customize everything when you're productizing is really hard to achieve under normal circumstances. So what ReNative tries to do is to create an ecosystem where you can have things like scoping. So you can build your template and you can scope it up. So when the project is using this template, anything which is referenced as a scope, whether it's a plugins of the functionality or the configuration, and then of course the standard things like dependencies of NPM and all that. This is pretty standard for normal projects. But what it does is that if you bootstrap your project, you are still connected to the product. Even you can actually start making changes directly in the project, and you're not disconnecting it from the, let's say, a product template. So if the next upgrade comes from the product, your project only gets all the updates, except the certain functionality areas and certain overrides. And again, I'm not talking just about the code. The code is pretty much covered in the standard solutions. This is about the infrastructure, the way how the project is set up, the way how the linking works across the plugins, the way how the features and A/B testing is set up for these features across these different projects instances. Product complexity, another part is that it's quite often needed to extend the functionality beyond just what is available. And when I was working on this idea, it was important that it would be possible to take any integration, any sort of functionality, and be able to inject it into the infrastructure. Without kind of creating sort of a pseudo solutions around it and some SH scripts and some kind of hacking scripts around how to solve some certain problems. Instead of, it is possible to build a very properly integrated solution which takes advantage of all these things ReNative offers to these integrations, things like awareness of the project, awareness of the right paths, of the security of everything what's happening, and at the same time then provide that functionality. So here's an example of I added integration for Vercel and integration for Docker. And what it does, what these integrations do, they load it dynamically into the infrastructure of your project when you add it to the project, for example. And suddenly you can use them directly in RNV console. So RNV Docker at that point becomes actual proper command, which gives you options of what to do. And because it's now integrated, it allows a quite interesting sort of connection to your project. So again, and the point is that it's possible then to productize these solutions rapidly and then offer them on the product as a part of the product, also directly on the projects as well. And of course, these are completely coupled, so they typically come from npm repository or any other repository, any other package repository you use. Another example would be the engines, which is kind of a next level, how far you can really push this. And it was very important that I personally, I'm a platform and framework agnostic. I don't have any real preference about any specific solution. And I think React Native works really well now, but who knows what will be the future. And one of the things which was important is that if we build a product which is utilizing React Native in this instance, it shouldn't be needed to rebuild the whole infrastructure, everything what you do, just because you change the kind of the framework you're using to build it. Of course, there's tons of refactor which might be required, but not by simply abandoning whole product just because you change the one layer of a technology stack. And this is where the engines come in. They actually work already right now. So if you, for example, seen the example, if you've seen that video a bit where the web run versus let's say the mobile, they actually were executed by different engines, which are separated because they focus on a specific functionality. And those engines themselves, they integrate the functionality of React Native. But it also means that you could actually have an engine which doesn't use React Native at all, and it could use something completely different. And yet your infrastructure does not really change. Go-to-market was one of the last issues. You can incorporate or create the multi-platform templates and use them to bootstrap the project. So the example you've seen was one of the templates, but actually it is possible to build a custom template with the custom functionality scoped in, let's say, in the company and use it. You can see here, there's a little snippet. When you bootstrapping a project, you can also choose a custom template, and then you simply provide a URL to your template, and then the ReNative basically loads that template but uses exactly the same approach afterwards. It does all the bootstrapping exactly the same way. And then the final thing is, once you bootstrap your project, the only thing you care about is I just want to run it straight away. I don't care what's behind, how it works. The first thing I want to see, it's running, and it's running across all these different platforms. That's the kind of philosophy behind. And the final thing was the security. So managing that security is a complex thing. So one of the things which I added to ReNative was ability to kind of manage it in a more structured way. This is sort of if anyone used Fastlane, you probably know the Fastlane recently introduced the ability to kind of manage your security keys. So you can think of this is something similar, but it's not exactly the same. Mind you, you can actually use RNV Fastlane as well with RNV. So ReNative has a support for Fastlane. So if you want to use a specific functionality of it, that's also possible. But this is sort of an option if you have a certain files or sensitive information which is all constantly needed for the project. You can actually make it encrypted, so you can and still use it in the project. What this removes, it removes the need to have a third-party management around this. The only thing really you need is, of course, access to repository, and then the single key, which is then managed by I don't know, the tools like LastPass or whatever is the security policy on every at every company. But what it does basically, it takes a certain area of the code base and it encrypts it. And that typically would be the things you need, for example, like certificates, provisioning profiles, maybe if you want to kind of send them as a whole bundle without adding anything extra, adding anything around the built infrastructure, you can actually do that. It does it with the AES encryption and CBC encryption. So it's an industry standard encryption, and it does it automatically when you do the decryption. So if you run your new project, again, the narrative is you should never run this. You should never need to run this manually. So you can run this manually, but if you haven't done this and there is a visibility for ReNative that, okay, you have encrypted files, you need to decrypt them first, it actually does that for you automatically, or it asks you, depending on what is your setup in the configuration. Okay, so that's the part about the way the way how it works and how it helped us to start thinking about the multi-platform, but also how to think about these specific problems. And as I mentioned at the beginning, at 25 we adopted React Native, but we needed something which would help us to push it to the next level. And really scale it up, really scale up and let developers to focus on those specific topics of React Native and all these experts in that area, and let the infrastructure to be something which is ideally managed in the most automated way possible. So what was the result then of all of this? So 25 product use case is the little snippet of what it allows us to do. It's something which evolves as we speak, but I can give you some snippets of what are the outcome, or what is the output of trying to integrate something like this into fairly large scalable ecosystem. So to build highly scalable multi-platform OTT ecosystem was the mission, because we really had to be able to scale it up across 50 plus projects. In the future, be able to maintain it, be able to change the parts of the infrastructure without sacrificing the maintenance flow of the projects. This is a constant battle, which was in the past. So the outcome was that we managed to build a product which is highly customizable, but and at the same time a very scalable. It can be productized and it can be bootstrapped really quickly. And there are a few snapshots here, as you can see how does it look like. This is OTT specific, of course, but ReNative itself is, of course, a very generic in this case. And you can see, like, for example, this is a snapshot of how these app configs, for example, would work. That you could even run. These are separate projects, but you could run the same project, take app config, and reconfigure your application. This is, of course, the custom product, which is proprietary to 24i, but it actually utilizes these features of the customization possibilities, which can be done very dynamically, and a few other potential snapshots. Now you might think of, okay, well, this is just a Photoshop. I hate Photoshop slides personally, so maybe the best way is to show you what you just seen. And let me show you this a little example. I'm just creating a new awesome OTT app. As you can see, it's the same infrastructure. It's a ReNative project. However, the product behind the scenes is a completely arbitrary. So what you see here is a 24i flagship product. It has nothing to do with a Hello World or anything like that. The only thing which is common here is the infrastructure. Is the ReNative infrastructure. The way how it works behind the scenes is very different. The way how the code is set up is very different. But what is same is the way how you set up your projects, how all these dependencies are cross-linked, and all these kind of advanced topics I discussed. We actually had to go through all these advanced topics here. And here you can see, I'm bootstrapping a new project. This is the way how our internal developers would bootstrap the project for the client. Now, typically, it would take quite a long time for a large-scale enterprise product to be bootstrapped for the client. Now, I'm recording this for 4 minutes, and this is essentially, again, it's a live recording. A couple of things are happening here, as you can see. There's a little bit more happening than on the Hello World. It's because there's all these different scoping, for example, that when you bootstrap your project, it basically becomes connected to the live product through these different scopes. But at the same time, it's possible to instantly start customizing it. So I'll just jump. What you can see here is there's a lot of things which are happening at the beginning, because I literally bootstrapped this from nothing. There was no code, there was nothing in it. And the first thing which was bootstrapped was the ReNative configuration. And then it went to the template, it went to all these dependencies, and it actually has to go through several cycles of installations, simply because they are nested dependencies of the product. It's much more complex than the standard project. So there are several even departments who are working on the different areas of the productization on this React Native solution. And if I would fast forward it a little bit into the third minute, as you can see, iconography was bootstrapped. Again, and that comes from a template. And again, it can be instantly changed here if I decide to that on this project I want to use a different iconography. Same with the other customization options as we speak. So as I go here, as you can see, the project now went through all these life cycles. Metro is running, app started, and what you're going to find here, there's a lot of initial output. That is only the first time. We're now launching the app, and as you can see, this is the Bootstrap app, exactly as on those screenshots, but now running live. And this is one of the templates we actually use when we bootstrap new projects. So this is a little kind of a preview how this infrastructure can help out to kind of build all these different complex products, and yet not to lose the standard elements of the infrastructure. So once you learn that, okay, well, I know as a developer, if I'm working in company X and I want to move into a new project, basically, I already learned everything from the infrastructure perspective. And of course, if your product is well designed, then the developers already know the product, and suddenly it opens up so much more room to really push your scalability of cross-platform infrastructure. I showed you just the mobile, but this platform is actually cross-platform. I don't have a time to show all the videos, but that's kind of what you can think of in terms of this rapid bootstrapping. So what is the future then for ReNative? So there's interesting things I've been thinking about and working with several people who contribute to this, how to kind of push it to other interesting areas. There's a lot of other platforms which already been investigating to cover. Probably the most interesting is, or the painful type of investigation will be Roku. As you all know, the Roku is not JS core based, and that would require some interesting solutions, which I've been investigating, how to kind of enable the JSX flavoring, that you can kind of treat the functionality when you build your product, that you could even build your project for Roku. And yet, if you know React Native, you kind of know most of it already. as well. Community engines, backend platforms, integration of AI for the CLI itself, because the CLI becomes the centerpiece of your execution. But it doesn't touch the actual final project and the product. It becomes very interesting exercise how this can be integrated with other areas of automatization of the ecosystem, including some predictability, some issues when the developers have the same issues over and over. You can, because everything is quite strictly going through the same process of same configuration ecosystem. It's a very interesting area to explore. Game engine is another interesting thing to incorporate. Android launcher is also. Apple Watch again is something which is interesting upcoming thing. Incorporation of ReNative Windows for the native rendering stack on macOS, and at the moment the macOS is running by Electron engines, and again you can actually switch. So if you build your project for Electron and it's React Native, as that's what ReNative does in that particular engine, you would be able to switch to a completely different engine based on, for example, React Native Windows, and you could actually run it in a similar way. So is ReNative the holy grail of the world? No, it's not, of course. ReNative is just one of the options, and also it's at very early stages, and I would think of ReNative sort of a Alice in the Wonderland rabbit hole a little bit, because it really was also the exercise of exploring how deep is that rabbit hole when it comes to can it really be pushed that a single rendering engine like React Native could be used on as many platforms as possible, and what will be the output. That's how it started, as a kind of a child interest. So it's important to understand, and I'm pretty sure that most of the audience here understands that, is that your technology should not dictate what you do. So as soon as you start build your strategy around the specific technology, it will become a religion essentially. And for love of God, don't do it. Technology should basically be just like a brushes on the painting. They are just brushes. They are just the ways how to get shit done. And the technology changes over time. And so for me, it's about picking the right tool to do the right job. And the thing is, the environment around the job sometimes changes. So that also means that the picking the right tool might change as well. It's never a constant. And another note about ReNative itself, it's still under active development. It's early beta. It's not well live tested as alternatives. Well, there are already some live projects and live clients and developments are happening. It doesn't mean that it can be compared anywhere near to other solutions which are on the market. And also it doesn't try to compete with these. It's a sort of a infrastructure help tool, which a goal is to incorporate these rather than trying to replace those such as solutions, these cross-platform solutions. It's still a limited amount of maintainers. It's still a fairly small project. Another thing is it has lack of tutorials, so it might be hard to understand at the beginning how the internals work. While the tip of the pyramid is pretty easy. You just kick it off and it's just working. But if someone wants to dive into the details, it probably might not be as easy as hopefully it will be in the future. And it needs more documentation as well, because of the infrastructure itself. What you can do with it is quite a substantial amount of stuff you can actually do with this, and that also requires some effort around really good documentation also for the future. And of course, great developers are the ones with childlike curiosity. So it's not about just that there is this tool. It's also about anyone who is a great developer always looks around, always gets interested. And I myself, I explore a variety of different solutions as well. And ReNative came out of a sort of a necessity of that layer of missing infrastructure setup for cross-platform apps rather than trying to build another cross-platform solution. So actually, anyone who looks at ReNative, I would also recommend to look at all these other solutions, because ReNative also sort of incorporates them. The goal is that in the future it would incorporate this variety of different solutions through this kind of a single way how you configure your ecosystem. And probably the final note, special thanks. I mean, this project is not done only by me. There are, of course, the guys at 25 deserves a big thank. There's a lot of engineers who spend their time and work on this, also supporting this project in general. So big thanks to the developers at 25. They're doing a great job. Also the contributors, of course, direct contributors, big thanks for anyone who contributed, no matter how small or big, into ReNative. It's really a big help. Big thanks for the backers who decided to chip in a few euros here and there to kind of show the support. Also, thanks for the React SEALs, who were one of the first kind of a team to kind of really start adopting this, and they provide also a lot of support, and they also contribute a lot to this project. And another special thanks to highlight one person, which probably was a great help and instrumental in building some parts of ReNative, and that's Mihai Blaga. He is one of the kind of developers who did a lot of brought a lot of value, and still kind of is in touch with ReNative and helps to kind of improve this. So that's basically it. That's the whole story. Just to note, ReNative is non-profit and open source. You can use it for any purposes. Of course, any help is appreciated, whether it's a PRs, bug reports, questions, mentions, stars, likes, donations. Again, it's not about scaling in terms of money. It's still essentially an exercise in what is possible in industry and in the future. And who knows what the future will behold. I don't know that myself. I'm not an oracle, but it's a very interesting a proposition to explore, and it was a lot of fun to kind of really diving into these different cross-platform topics, and not just with the ReNative, but also throughout the years of my career as well as a developer. And that's pretty much it. Thanks everyone for listening.